Hi, Assalamualaikum. This is our video presentation for STA T23 group presentation. Our title is Student Performance. We are from class D1 CDCS 1113A and this is our group members.
First, let's start with introduction. Monitoring student study hours helped identify learning patterns, time management, and academic discipline. This study analyzed weekly study hour data from 25 students over 5 weeks using statistical process control SPC techniques, including XBAR, R, S, P, and NP charts, supported by manual calculation and Microsoft Excel. The analysis aims to assess process stability and determine the consistency of students' long-term study behavior over time. We have three objectives for the case study. First, to determine the means of students' long-term study hours for a week using an X-bar chart. Second, to determine the range and standard deviation of students' long-term study hours for a week using an R chart and S chart. Third, to determine the fraction of nonconformities and the number of nonconforming students' long-term study hours for a week using the P chart and the NP chart.
So for the description of data, the study used data of student long-term study hours for a week (SH). The data consists of weekly study hours recorded for 24 students over a period of 5 weeks. The variable includes student ID, long-term student hours for each week from SH1 to SH5 and the weeks. The dataset is used to analyze the variation and pattern of student study behavior over time. So the variable that we use is student ID, which is discrete qualitative, long-term study hours, which is continuous quantitative, and weeks, which is discrete quantitative. Moving on to the sample size, the data represents student long-term study hours for a week (SH). The sample consists of 25 hours. Each student recorded their study hours for 5 consecutive weeks. The data collected on a basis for each student throughout the study period.
So for the next slide, the analysis of data will be discussed. So for the control chart that we use is X chart, R chart, P chart, NP chart, and S chart. So next, we will moving on to the manual calculation. So figure 1 shows manual calculation for X chart and R chart. So this is the formula that we use to find the value. Next, we will moving on to the figure 2. So figure 2 show the manual calculation for X chart and S chart. So this is the formula that we use to find the value for X chart and S chart. And the last one, figure 3 shows manual calculation for P chart and NP chart. So this is the formula that we use for P chart and NP chart to find the value. Moving on, we will proceed to the Microsoft Office Excel. So this is how we calculate this using Microsoft Office Excel to find the value for X chart and R chart. Next, this is our formula that we use based on the Microsoft Excel to find the value of the X chart and S chart. And the final one, this is the formula that we use for the P chart and NP chart to find the value using Microsoft Excel.
Now, I would like to show the calculation for mid and range chart. First, we would like to calculate the central limit, lower central limit, and upper central limit for x chart. For the central limit is with the formula S bar is equals to summation of x divided by m, and then we get 477.4 divided by 25 is equals to 19.096. For the R bar is equals to summation of R divided by m is equals to 358 divided by 25 when we get 14.32. For lower central limit, the formula is x bar minus a2 times r bar, and we get 19.096 minus 0.577 times 14.32, and then we get 10.8334. For upper central limit, this formula is x bar plus a2 times r bar, and then we get 19.069 plus 0.577 times 14.32. And then we get the final answer is 27.35 and 27.3587. In the next slide, I would like to show the graph for the S chart. For R chart, the central line is equals to R bar, which the formula is summation of R divided by M, and then we get 358 divided by 25, and we get 14.32. For lower central limit, the formula is D3 minus R bar, which is 0 minus 14.32, and then the answer is negative 14.32, since the value that we get for LCL is equals to is negative number, so the LCL will be 0. For upper central limit, the formula is D4 plus R bar, which equals to 2.114 plus 14.32, and then the answer is equals to 16.3434. And then I would like to show the graph for R chart in the next slide. For the next calculation, I would like to show the calculation for mean and standard deviation chart. First, for the X bar chart, the formula for central line is same as before, which is X bar is equals to 477.5 divided by 25, and we got 19.096. For the standard deviation chart, we have to calculate the S bar, which is equals to summation of standard deviation over 25, and then we get 152.638 divided by 25 is equals to 6.1055. For the lower central limit, is equals to S bar minus A3 times S bar, and then we get 19.096 minus 1.427 times 6.1055, and we get 10.3835. For upper central limit is equals to S bar plus A3 times S bar, and then we get 19.069 plus 1.427 times 6.1055, and then we get 27.8085. Next, I would like to show the calculation for central line, lower central line, and upper central line for S chart. For the central line is equals to S bar, which is 6.1055. For lower central limit is equals to B3 times S bar, which is 0 times 6.1055, and we got the LCL is equals to 0. For upper central limit, the formula is B4 times S bar, which is 2.089 times 6.1055, and is equals to 12.7544. And in the next slide, I would like to show the graph for the S chart. Next, I would like to show the calculation for P chart, and for the central line is equals to P bar. With the formula is summation of P divided by M, and then we get 1.59133 divided by 25, which the final answer is equals to 0.06365. For lower central limit, the formula is P bar minus 3 times square root P bar times 1 minus P bar divided by N, which is N is equals to 1,500. And then we get the answer is 0.06365 times 3 times 0.006303. And the answer for the lower central limit is equals to 0.0444741. For upper central limit, the formula is equals to P bar plus 3 times square root P bar times 1 minus P bar divided by N. And then we get 0.06365 plus 3 times 0.006303. And then final answer is, the final for UCL is equals to 0.08256. Based on the graph for P chart, we can see that there are 2 points that is out of control limit. So I would like to show the calculation for the revised control limit for P chart. For CL is equals to 1.76667 over 23 is equals to 0.06377. For revive for lower central limit is equals to 0.06377 minus 3 times 0.006309 is equals to 0.044843. For upper central limit is equals to 0.06377 plus 3 times 0.06309 is equals to 0.0826697. Next, I would like to show the calculation for MP chart. This for the central line is equals to MP bar, which the formula summation of MP divided by M, and then we get 2387 divided by 25 is equals to 95.4348. For lower central limit, the formula is NP minus 3 times square root NP times 1 minus P bar. And then we get 95.48 minus 3 times 9.45553 is equals to 67.1141. For upper central limit, the formula is MP bar plus 3 times square root MP bar times 1 minus P bar, which is 95.48 plus 3 times 9.4553. And then we got 123.8494959. Based on the graph I showed before, we can see that in the MP chart, there are 2 points which is out of control limit. Now, I would like to show the calculation for revived control limit for MP chart. For CL is equals to 2,200 divided by 23 is equals to 95.6522. For lower central limit is equals to 95.6522 minus 3 times 9.4632, and we get the answer for revived SCL is equal to 67.2626. For upper central limit is equals to 95.6522 plus 3 times 9.4632, and then we get the permanent answer for upper central limit is equals to 124.0418.
So next is the Microsoft Office Excel. We convert the data into graph using this Microsoft. So the first chart is X bar chart. This X bar chart tracks our process stability over 25 samples. So you can see the peak at sample 10 and dip at sample 20, but the value never crossed the control limit. Since all of the data points lies between the control limits, the X bar chart indicate that the process is under statistical control. The second chart is arc chart. This chart confirms the consistency. On the arc chart, sample 12 show the lowest variation and sample 3 is the highest variation. Since all of the data points lies between the control limit, the arc chart indicates the process is under statistical control. So this chart is similar to the previous chart. This data show the process that is in control, and since all of the data points lie between the control limits, the X bar chart indicates that the process is under statistical control. The next chart is S chart. As you can see, the highest variation is sample 13 and the lowest variation is sample 12. This chart is not cross the limit and still in the control limit. Since all of the data lies between the control limit, the S chart indicates that the process is under statistical control. So next is P chart, which we are using to monitor the stability of our process by tracking the proportion of non-conforming. As you can see, in this chart, most of the data points are within the boundaries, so we have two significant that out of the control, and that is sample 10 and sample 20. Because it is outside of the limit, we need to revise the control limit. So for the last chart is NP chart. This chart is the charts of number of non-conforming items. Most of the data points stay within these two lines. The process is considered stable. However, from the plot, the process is currently out of statistical control, so we cannot claim this process is stable or predictable, and we need to revise the control limit.
In conclusion, this study applied statistical process control SPC techniques to analyze students' long-term study hours over a 5-week period. X bar, R, and S chart were used to assess the stability, central tendency, and variability of study hours, while P and NP charts examine the proportion and number of non-conforming study behaviors. Overall, the analysis provided insight into the consistency and stability of students' study pattern over time. Based on the findings, it is recommended that SPC tools be used to continuously monitor student study behavior to detect inconsistency at an early stage. Students are encouraged to maintain consistent study schedule and improve time management skills. Future studies may consider using a larger sample size or a longer observation period to obtain more reliable results.